Recording now, this is lesson 7.3, a continuation of algebraic expressions. Before watching the recording, please make sure that you have a graph sheet of paper in front of you, a pencil, a different colored pen or a highlighter, as well as a ruler. So if you need to pause the recording to get those items, please feel free to do so. Now, I'm going to begin the lesson by reviewing the meaning of algebraic expression. So if you recall from the previous 7.3 video, an algebraic expression was defined as a phrase that uses operations with numbers, variables, or both. And the last video cut off the very last algebraic expression we were trying to interpret. So to refresh your memory, that last algebraic expression was a two-step one. It was 45y minus 75. So this is a combination of multiplication because you have a number touching a variable, which indicates multiplication, and you have subtraction. So the way we interpret this is multiply the number that y stands for by 45 and add 75 because this is a two-step. And it's appropriate because the second part of this lesson will deal with finding the pattern from t-tables and converting that pattern rule to an algebraic expression. We're going to use your textbook, so if you refer to Math Makes Sense, page 20, I'm going to highlight the question we're going to be looking at. So it's this question here we'll take a look at. It says Manoa works at a fishing camp in the Yukon. Manoa earns $25 a day plus $8 for each fishing net she repairs, and that's key to understanding how to set up the t-table. On Saturday, Manoa repaired 9 nets. How much money did she earn? So we'll approach this by setting up a t-table, and I'm not necessarily going to go up to 9. I'll probably go up to 6, and we can, once we determine the pattern, then we can predict how much money she earns at 9 after repairing 9 nets. So the way you would set up your t-table is the following. So I'm just going to set it up like this. Now, I'll use a pencil here. So anything that I write down in black pen, you should be jotting down on your page in pencil. The left side of the t-table is typically the input set of values. In the case of this question, it's the number of nets repaired, fishing nets repaired. Now in this case, I'm going to call it X. Just remember from previous lessons, it's also called the input, if you can see that. The right side of the t-table will be the amount of money earned. And that'll be in dollars. This is the output. Okay, now I'm not going to label this Y necessarily. I'm going to leave it as just being the output because we're going to be looking at things in terms of X. And I'm just going to highlight those 3 elements so that you're drawing your attention to it. Now, for our table of values here on the input side, we're going to go from 0 to 6. And you do the same. Okay, now we have to look at the information given in the problem. It states that she earns $25 per day, and that's with no nets being repaired, okay? She earns $8 for each net she repairs. So even if she didn't repair any nets, she still earns $25 that day, even if she repairs 0 nets. Now, if she repairs 1 net, and now you can see how the pattern rule applies, she's still going to earn $25. So in your head, you're thinking, okay, $25 plus she repaired 1 net that day, so she's going to earn an additional $8. So 25 plus 8 will give you 33. If you look at this at 2 here, the input value of 2, that indicates she repaired 2 nets that day. Remember, she still earns $25 a day if she doesn't repair any nets. So that has to factor into your calculation. And then she's going to earn $8 for each net that she repairs. In this case, it's 2. She repairs 2 nets. So you know it's going to be 8 times 2, which is going to be 16, plus the $25 she earns that day, even if she doesn't repair any nets. So your total is going to be $41 earned that day. I'll do number 3 with you. Okay, so with 3 nets being repaired, because she earns $8 for each net, the calculation will be 3 times 8, which is 24. And then 24 plus the $25 she earns each day, that will give you a total of 49. Now pause the recording if you can do 4, 5, and 6 on your own. And I'm just going to continue here. For 4 nets, you know that she's going to get $8 per net, so that will be 4 times 8, and then plus the 25 on top of that, and then she will get $57. For 5 and 6, if we follow the same pattern, she'll earn $65, and then she'll earn $73. Now, hopefully by now you've been able to see how the 25 and the 8 play into the rule. Now, in the previous lesson, we would have reported this as you're multiplying the input number by 8, and then you're adding 25. Why is this the case? Well, remember, in each case, she's repairing a certain number of nets. She earns $8 for each net, so you're always going to be multiplying 8 by the input number. Remember that the $25 per day, she always earns it regardless of how many nets she repairs. So that just gets tagged on to however many nets she repairs. So that's adding 25. Now, to look at it in terms of an algebraic expression, we're going to use x as our variable. Now, remember that you're actually multiplying the input number by 8. Okay, so I'm just going to write this down. First, multiply the input number by 8 and add 25. Oops. Okay, let me erase this for a second here. Okay, I'm going to repeat. So, essentially what you're doing is you're multiplying the input number by 8. If we take the whole list of input numbers here, we know that each time, and I'll write this in red, you multiply it by 8 and you add 25. Okay, so it's clear in the second example. 1 times 8 is 8. 8 plus 25 is 33. 2 times 8 is 16 plus 25 is 41. So each time you're going to be doing that. So that's why we can make a generalization with the pattern where you're multiplying the input number by 8 and adding 25. So we can easily convert this into an algebraic expression. The way we would write it as an algebraic expression is the following, and I'm going to do this in a different color down here. We're going to just reverse this and go 8x plus 25. That is the algebraic expression that describes the pattern rule for this t-table. We're multiplying the input number, which is x, and remember we associated input with x at the beginning, and then you're adding 25 because it's a total that she always earns. Okay? Now we can answer the second part of this question, and I'm just going to jot it down over here. I'm going to highlight the second part because now that we have the algebraic expression, we don't necessarily have to extend the t-table to find out how much money she's going to earn for repairing 9 nets. We can simply figure that out using the algebraic expression. If our input number is 9, sorry, I'm just going to, if you can continue this on your graph sheet of paper. If the input number is 9, we're simply doing 9 times, sorry, it should be 8 actually. We start off with 8. We know that the algebraic expression is 8x plus 25. So we're going to do 8 times 9. This indicates multiplication. 8 times 9 is 72 plus 25, which equals $97. Therefore, and we would do this in a sentence if I had room, she would earn $97 for repairing 9 nets using this algebraic expression.